Welcome to Module 5 of the Certificate 4 of Project Management course, presented by Charter Australia. Module 5, Quality Management. In this module, we will identify the key elements which contribute to project quality and discuss the steps required to achieve desired quality. Project quality is all about producing an outcome which will satisfy what was requested, that is, satisfy the purpose for which it was intended. Quality can also be looked at in terms of meeting expectations, that is, meeting the needs of the customer. It is important that both these points are satisfied. It's no good if the quality requirements of the customer for a product are initially met, but that product does not eventually meet the customer's requirements for durability, for example. Because producing quality is a cost both for the project and the customer, it is important that the quality attributes of deliverables be clearly defined at the beginning of the project. Along with scope, time and cost, quality is one of the key elements of project management. As mentioned earlier, it is one of the 4 key project controls. Unless the project produces a quality result, it will not be successful. Quality management requires making use of the 3 P's: product, process and people. Product. In order to ensure that the project's understanding of the quality of the project deliverables is consistent with that of the customer, it's important to define the attributes of the product in terms of quality. Product quality measures and techniques are specific to the type of product produced by the project. Whilst quality measures and techniques for developing an IT system differ from building a nuclear power plant, project quality management applies to both. Failure to produce a quality outcome will have serious consequences for the project. For example, meeting a project schedule objectives by rushing planned quality inspections may produce a poor quality product when errors go undetected. The project management team must be careful not to confuse quality with grade. Grade is a category or rank given to entities having the same functional use but different technical characteristics. Low quality is always a problem. Low grade may not be. For example, a software product may be of high quality, that is, no obvious bugs, readable manual, and low grade, a limited number of features. Determining and delivering the required levels of both quality and grade are the responsibilities of the project management team. Processes. Quality processes are activities which are aimed at producing a quality outcome. Examples of quality processes are documentation reviews, testing, inspection and audit. People. It's important that project team members understand their roles in contributing to a quality outcome for the project. Some project teams have quality managers who are focused on managing all aspects of project quality. Remember, all the above factors must be considered in your quality plan. Quality management supports project management by ensuring that the project work is done well. Good quality will result in customer satisfaction by ensuring that their requirements are met. It supports prevention of errors rather than correction. Error correction is rework, that is, doing work again. Rework costs a lot more than prevention. It supports the appropriate planning and resourcing of the project to ensure that enough people and enough time are built into the schedule for quality activities. Finally, it supports continual improvement through a constant review and improvement cycle. That cycle is plan for quality, do the work, check the quality, and act by improving quality processes. The first step is quality planning. The quality management plan in the PMP should describe how the project management team will implement its quality policy. It should describe the project quality system, the organizational structure, responsibilities, procedures, processes and resources needed to implement quality management. The PMP template provided in your resource kit provides you with a guide for what should be included in the quality management plan. It should also provide references to the government, industry or organisation standards with which your project must comply. Most industries have standards. For example, the Travel Agents Act governs the travel industry. The Environmental Protection Act governs any projects which may have an impact on the environment. In addition, there should be a specific quality plan for each project deliverable. This will describe the acceptance criteria for each deliverable and what processes the project will undertake in order to ensure the desired quality is produced. For example, what reviews will be included, what testing or inspections will be undertaken, will there be any trial runs of the product. For technical projects, the quality plan is often supported by detailed documents such as detailed testing plans containing an overview of each test to be performed and the expected outcomes. Quality assurance. Quality assurance is all the planned and systematic activities implemented within the project to provide confidence that the project will satisfy the relevant quality standards and customer requirements. Quality assurance activities should be planned during the planning phase and included in the quality plan. They should then be performed throughout the project and reviewed for their effectiveness. This creates a continuous improvement cycle where wasteful or inefficient activities can be improved, thus increasing efficiency and effectiveness of project processes. Examples of quality assurance processes are testing. The development of computer software goes through various levels of testing such as component or unit testing, system testing, and finally user acceptance or business testing. All levels of testing are carefully documented and managed by specialist groups of people. Inspection and checking. This quality assurance process applies to all projects and can be document reviews, inspection of completed components of work by external inspectors such as in the building industry. Prototyping or trial runs. This quality assurance process is used in industries such as manufacturing and software development, where a small number of products are produced and tested prior to launching into full production and rollout. This approach is more cost effective as any errors or defects to be fixed will only need to be applied to a small number of units. And audit. This is a key quality assurance process. Most large projects are audited by either internal or external auditors. The emphasis on these audits is to ensure that the project is doing the work according to agreed procedures and plans. Quality control. Quality control involves monitoring specific project results to determine if they comply with relevant quality standards, and identifying ways to eliminate causes of unsatisfactory results. It should be performed throughout the project. Quality control is the actual act of applying the quality assurance processes of checking or testing against predefined quality standards. Any defects or mistakes that are identified must be rectified. The results of the quality control processes must be documented, as they are input to the final approvals when the deliverables are handed over to the customer. Quality processes cost money, so there must always be a trade-off between the amount of money spent on quality assurance processes within a project versus the cost of rectifying errors at the quality control stage. The cost of rectifying errors gets higher as the project progresses, so a suitable amount of money should be allocated to optimizing the quality of the product as soon as possible. The diagram on this slide illustrates the ratio of the cost of fixing quality problems as the project progresses. At the top of the pyramid, we see that the cost of fixing problems at the point at which they occur, for example when a component part is manufactured, has a factor of 1. Once the defect has been incorporated in other project work, for example the component has been installed into the final product, the cost of dismantling and then fixing the defect will be a factor of 10. Finally, if a defective product is supplied to the customer and the customer finds the defects and has to return the product for rectification, the cost factor will be 100. At this point in time, the cost factor not only includes the cost of replacing the defective product, but the cost of damaged company reputation and possible loss of business. This ends Module 5, Quality Management. Please read Module 5 in your UNEP textbook, especially the last section, which covers the statistical techniques which can be applied when doing quality control. You now need to complete the following assignment for your case study project and submit it to your tutor: the quality plan. Please refer to the case study, assignment instructions and supporting templates.